Hello, welcome to the next section of the course, Building a Retail Recommendation Engine. In this section, the reader will learn what is recommendation and how does it work, types and methods for performing recommendation and implementation of product recommendation using R. Let's start with the first video of the section, what is recommendation? In this video, we'll look at the need of recommendation, types of product recommendation, and techniques to perform recommendation. Recommendation is the method or technique by which an algorithm detects what the user is looking at. Recommendation can be of products, services, food, videos, audios, images, news, articles, and so on. What recommendation is can be made much clearer if we look around and note what we observe over the internet day in and day out. For example, consider news aggregator websites and how they recommend articles to users. Look at the tags, timing of the article loaded into internet, number of comments, likes and shares for that article, and of course geolocation, among other details. And then model the metadata information to arrive at a score. Based on that score, they start recommending articles to new users. The same thing happens when we watch a video on YouTube. Similarly, beer recommendation system also works. The user has to select any beer at random based on the first product chosen. The algorithm recommends other beers based on similar users' historical purchase information. Same thing happens when we buy products from online e-commerce portals. Types of product recommendation. Broadly, there are 4 different types of recommendation systems that exist. Content-based recommendation method, collaborative filtering-based recommendation method, demographic segment-based recommendation method, association rule-based recommendation method. In content-based method, the terms, concepts, which are also known as keywords, define the relevance. If the matching keywords from any page that the user is reading currently are found in any other content available over the internet, then start calculating the term frequencies and assign a score, and based on that score, whichever is closer, represent that to the user. Basically, in content-based methods, the text is used to find the match between 2 documents, so that the recommendation can be generated. In collaborative filtering, there are 2 variants, user-based collaborative filtering and item-based collaborative filtering. In user-based collaborative filtering method, the user similarity is computed by the algorithm, and then based on their preferences, the recommendations are generated. In item-based collaborative filtering, item-item similarity is considered to generate recommendation. In demographic segment-based category, the age, gender, marital status, and location of the users, along with their income, job, or any other available feature, are taken into consideration to create customer segments. Once the segments are created, then at a segment level the most popular product is identified and recommended to new users who belong to those respective segments. Techniques to perform recommendation. To filter out abundant information available online and recommend useful information to the user at first hand is the prime motivation for creating recommendation engines. So, how does the collaborative filtering work? Collaborative filtering algorithm generates recommendations based on a subset of users that are most similar to the active user. Each time a recommendation is requested, the algorithm needs to compute the similarity between the active user and all of the other users based on their co-rated items, so as to pick the ones with similar behavior. Subsequently, the algorithm recommends items to the active user that are highly rated by her most similar users. In order to compute these similarities between users, a variety of similarity measures have been proposed, such as Pearson correlation, cosine vector similarity, entropy-based uncertainty measure, and mean square difference. Let's look at the mathematical formula behind the calculation and implementation using R. The objective of a collaborative filtering algorithm is to suggest new items or to predict the utility of a certain item for a particular user based on the user's previous likings and the opinions of other like-minded users. Memory-based algorithms utilize the entire user item database to generate a prediction. These systems employ statistical techniques to find a set of users, known as neighbors, who have a history of agreeing with the target user. That is, they either rate the same items similarly, or they tend to buy similar sets of items. Once a neighborhood of users is formed, these systems use different algorithms to combine the preferences of neighbors to produce a prediction, or top-end recommendation for the active user. The techniques, also known as nearest neighbor or user-based collaborative filtering, are very popular and widely used in practice. Model-based collaborative filtering algorithms provide item recommendation by first developing a model of user ratings. Algorithms in this category take a probabilistic approach and envision the collaboration filtering process as computing the expected value of a user prediction, given her ratings on other items. The model building process is performed by different machine learning algorithms, such as Bayesian network, clustering, and rule-based approaches. One critical step in the item-based collaborative filtering algorithm is to compute the similarity between items, and then to select the most similar items. The basic idea in similarity computation between items I and j is to first isolate the users who have rated both of these items, and then apply a similarity computation technique to determine the similarity, S, brackets I, j. There are a number of different ways to compute the similarity between items. Here we present three such methods. These are cosine-based similarity, correlation-based similarity, and adjusted cosine similarity. Cosine-based similarity. Two items are thought of as two vectors in the m-dimensional user space. The similarity between them is measured by computing the cosine of the angle between these two vectors. Here is the formula for computing cosine similarity between two vectors. Let's take a numerical example to compute the cosine similarity. So cosine similarity between d1 and d2 is 44%. Let's talk about correlation-based similarity. Similarity between two items, I and j, is measured by computing the Pearson R correlation core. To make the correlation computation accurate, we must isolate the co-rated cases. Adjusted cosine similarity. One fundamental difference between the similarity computation in user-based CF and item-based CF is that in case of user-based CF, the similarity is computed along the rows of the matrix, but in case of the item-based CF, the similarity is computed along the columns, that is, each pair in the co-rated set corresponds to a different user. Computing similarity using basic cosine measure in item-based case has one important drawback. The difference in rating scale between different users is not taken into account. The adjusted cosine similarity offsets this drawback by subtracting the corresponding user average from each co-rated pair. The example is given in Table 1, where the co-rated set belongs to different users. Users are in different rows of the table. What assumptions are necessary for our recommendation engine? The dataset we're going to use for this section contains 100 jokes and 5,000 users, which is a built-in dataset in the Library Recommender Lab. The dataset contains real ratings expressed by users in a scale of -10 to +10. With -10 being the worst and +10 being the best joke. We'll implement various recommendation algorithms using this dataset. Using this dataset, the objective is to recommend jokes to new users based on their past preferences. In this video, we've stepped into the world of recommendation engines. There's a lot more to come.